Okay, today we're going to continue representing fractions or finding equal parts using models. So we are focusing on fractions are division and interpreting fraction word problems as division sentences. So here we see a recreation center has a batting cage with a machine that pitches balls to the batter. So that is not going to be important information when we start to solve this problem, but it is important information to create a visual. So we talked last week about when I was younger, they called word problems story problems. And it's a story problem because the idea is to create a visual or a movie in your head about what's happening to help you solve this problem. So that is important information to create that visual in your head. It's saying a batting cage with a machine. We know that a batting cage with a pitching machine is going to pitch balls to the batter so that they can practice getting better at their swing and hitting the ball. But it's not going to be important information to solve this problem. So once I read it and I understand it, I'm going to get rid of it. Now it says 5 friends sign up for 1/2 hour of time in the batting cage. If they share 1/2 hour equally, how much of a whole hour will each friend get in the batting cage? And there is some important information here. I'm going to read it again and pull out the quantities. Quantities meaning the numbers. So 5 friends. This is a word, but it is a number. It's giving us part of the quantity to solve the problem. So we know 5 friends sign up for 1/2 hour. This is a fraction, but it's also a number, so a quantity. So we're going to pull that quantity out as well. If they share, this is going to be important as well, share 1/2 hour, another word quantity, but still representing this fraction, equally. How much of the whole hour will each friend get in the batting cage? So share equally. When we share something equally, we divide. That's whether we're working with fractions or integers as whole numbers. How much of the hour will each friend get? Okay, one last important piece of information, that is, what is the question asking us? That is asking us what each friend, or if they rent that batting cage for 1/2 hour, how much will each of the 5 batters get out of the whole hour? So even though we're dividing or sharing equally time from that 1/2 hour, really we're solving for 1 whole hour. So let's start here with our model with the 1/2 hour. So this part of our model is going to represent 1/2 hour. I know that 5 friends are sharing 1/2 hour. So that means this bar model or this bar fraction needs to be 5 equal pieces. So friend 1, friend 2, friend 3, friend 4, and friend 5. Now I'm going to use this tool. Remember, we're learning how to use Jamboard as well. Most of you are pretty fluent in it now, but if I go back and choose the pointer and select it, then I can duplicate it and get the exact same shape that I was working with. So this part is going to represent my other 1/2 hour. So that means if this 1/2 hour was split between 5 people, we had 5 equal parts. So the other half has to be, for it to be equal parts, we need to represent this as 5 equal parts as well. So we have friend 1, friend 2, friend 3, friend 4, and friend 5. Now, this would have been 5 pieces, but since it's 1/2 hour from here to here, and we're solving for 1 whole hour, then that means I really need to count the pieces all the way to the end here. So this is going to be out of 10 pieces. So if half was 5 pieces, 1, 2, 3, 4, 5, and our denominator would have been out of 5 here, we're solving for the whole hour. So it really takes some thinking there and struggling with these words a little bit to get an understanding of exactly what the problem is asking. So because it's all 10 pieces for the whole hour, our denominator is going to be 10. But let's go back to the original part of the problem where we're solving for how much does each friend get out of that 1/2 hour. So I'm going to just represent one friend here. And if we were thinking about just the half hour, then this friend would have had 1/5 of the 1/2, 1/5 of 1/2. Let me write that down, 1/5 of 1/2. We talked a lot about this last week. That word of will get replaced with that multiplication sign. So if we were solving it as a fraction model, we could count we've got one piece out of 10. And if we were solving it as an algorithm, even though we used division to create our model, we can use the words to make a computation sentence. So 1/5 of 1/2 is 1 times 1 and 5 times 2. And we end up with the same answer. So hopefully your mind is not blown that we used a multiplication sentence or a multiplication equation to solve a division problem. Hopefully you're remembering now, because you hear me say it all the time since the beginning of the year, that multiplication and division are inverse, meaning they're closely related, which means one is the opposite of the other, and you can always use one to solve the other. So really quick example here, just so that we can relate them one more time. If I said 5 times 2 is 10, then that means I also know 10 divided by 2 is 5. So these are inverse. They're related. So one is, I don't want to say the opposite, but one undoes the other. So 5 times 2 is 10, just like 10 divided by 5 is 2, or 10 divided by 2 is 5. All right, so our answer here, out of the whole hour, each batter will get 1/10 of an hour. So 1/10, let me type it in here so that we have our answer and you have access to it while you're working on yours in your workspace. So each batter one-tenth, or will bat 1/10 of an hour. Gets is probably not the best word. All right, let's take a look at the next one. The distance around the track at the recreation center is 1/4 mile. Maida, Will, and Holly plan to divide the distance evenly to practice sprints. What distance does each person run? So this time we're going to use a fraction circle. And so I know that Maida, Will, and Holly plan to divide the distance evenly. So we are going to start with representing the 1/4 of a mile. So we're going to represent that in this space. So if Maida, Will, and Holly plan to share or divide, it tells us divide right here, divide the distance evenly, then I need to divide this area 3 times. So this is going to get 3 more lines to divide it. Let's see if I can, maybe I should have used a rectangle one when I'm trying to draw this. It's not quite in the middle, so we're going to say 1, 2, let's divide it there. No, I'm going to have to use a rectangle. Sorry, guys. I just can't draw really well with the circle. I thought it was a good idea. All right. Okay, so to go back and choose a rectangle, get rid of this too. Then I'm just going to go over to my tools on the side. Erase that. I'm going to go over to my tools on the side and choose a rectangle. It seems to be a little bit easier when you're using the mouse pad. If you're drawing on paper, you can do the circle models a little bit easier. So that is your choice how you want to represent it. All right, So we know that they are sharing 1/4 of a mile. So the first thing I need to do, I'm going to make this even bigger so I don't have to squeeze my writing. So if this represents 1 whole mile, I'm going to break this fraction into fourths here. Okay, so this represents 1 whole mile. This part represents 1/4 mile. So if Maida, Will, and Holly plan to divide the distance, then that means this 1/4 mile is going to be 3 parts. So I'm going to color that piece in. Then I'm going to, since this was 3 parts, that means each piece of that mile, if this was 2/4 mile, and this represented 3/4 mile, and this was going to represent 4/4 mile, or the whole mile, I need to figure out of that mile by breaking each, if it's equally, each piece has to have 3 parts. 1, 2, 3, and 1, 2, 3. All right, so how much of each, or divide it distantly, how much does each person run? It would be 1 out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 1/12 mile, or 1/12 of a mile. Okay, let's check our thinking with that inverse operation. So if they're going to run 1/4 divided by 3 people. Okay, so this is going to be something that you will not need to know until 6th grade, but I'm going to show you how to check this problem using an algorithm with a trick. I'm not a big fan of tricks, but this is something that just kind of sticks in our head, and it is K, C, F is the strategy. So it's keep, change, flip. So when we are dividing fractions, or dividing with fractions, this fraction, we know that we don't do anything with a whole number, so this really says 3/1. Keep, change, flip. Let me grab a different color so I can really show you. Keep stands for keep the first fraction. Change stands for change the sign. So 1/4, I'm going to change the sign to change it to multiplication. So keep the first fraction, change the sign to multiplication, and last, flip. I wish there was a better way to say this. Flip means to flip this fraction. That is called the reciprocal. So when we are dividing, we're going to find the reciprocal by flipping the numerator and the denominator. So the numerator becomes 1 and the denominator becomes 3. So we flipped it. So now we're going to check our thinking, or check our model over here by using the keep, change, flip. That's not part of your 5th grade standards. It's just a trick. So 1 times 1 is 1, and 4 times 3 is 12. You're not required to learn that. It's just a way to check our answers. We love ways to check to make sure that we are on track. All right, guys, you have a couple problems today. As usual, if you need my assistance, you can hit the share button and share it with me at Duplin Schools, and send a little message with it which problem you need help with. Let me know what you need. Have a great day.